Welcome to the class of Microwave and Radar Engineering. This is lecture number 9 and I am Himanshu Nagpal from EC Department of AKGEC Ghaziabad. Today we will discuss about the microwave components and E-plane T. So first topic is your microwave component. In the microwave component, we will discuss about the we will discuss first that is 3-port junctions. In 3-port junction, E-plane T is there and the H-plane T. The next one we will discuss about the 4-port junctions. In this we will discuss about the hybrid T, that is also known as the magic T or EH-plane T. And next one we will discuss the hybrid ring, direction couplers and the hybrid coupler. Next we will discuss about this in this unit, that is the ferrite devices, it is isolator and circulator. So these are the microwave components which are help in transmission, which will help in transmitting the microwave signal from one port to the another port. Clear? So introduction is microwave power dividers, hybrid and couplers are an important part of a microwave system. In this we generally use to separate or couple a required amount of electromagnetic energy in a transmission line. Means we will like say if I say I want to, if this is a electromagnetic energy and this electromagnetic energy is want to get into split into 2 parts, or you can say microwave signal, it's divided into 2 parts, that is part 1 and part 2. So for that we need to have a microwave components, and the microwave component, if I am dividing this into 1 and 2 part, that is known as the microwave power dividers. Clear? This power may be divided into 2 parts, equal parts, 50% or 50%, and it can be divided into 25 or 75%. Clear? And these are also used in antenna beam forming, combining feed to and from antennas, signal monitoring, measurement and the power feedback. These components are also used in microwave antenna beam forming. Means if two antennas, if one antenna is getting a signal from this and another in this antenna also getting a signal from this area, means from both sides, so these component will add up on the the 2 signals. Clear? Different type of power dividers were also invented in order to operate the microwave range. Out of them, T junction, hybrid junction, rat race and Wilkinson power divider are the most important and the well-known components of the in the area of microwave components. Based on the number of power ports available, power dividers and couplers are categorized into 2 types, that is 3-port and the 4-port network. 3-port networks are the devices in which 3 ports will be there, and that is known as the E-plane T and the H-plane T junctions. Whereas the magic T junction, rat race junction, circulators, bath hole couplers, multi-hole direction couplers, swinger couplers, these are the 4-port network. These are the examples of what? 4-port networks. Now T junctions power divider are the 3-port power divider or combiner. Means there can be a division of power and there can be a combination of power that is used to split the power fed at one port, designated port, among the other 2 ports to combine the power at the 2 designated port and the 3rd port. Clear? Now if I say, let's simply if I say T junction having a 3 ports, let's say if this is the first port and this one is the device and this is the 2nd port and this one is the 3rd port. Now first, 2nd and your 3rd port, So if I want to give the energy into the first part, this can be, whole energy can be sent to the port number 3, or 50% of energy can be sent into the port number 3. And if I want to give the energy from the port number 3, if I want to give the energy from the port number 3, then this energy can be divided into two parts, port number 1 and the port number 2. Clear? So first we will discuss for the 3-port junction, that is the E plane T. So E plane T is a junction, or is a microwave device in which, let's say, if I say this is a waveguide, this is a waveguide, and this waveguide has one port, that is port number 1, and this is port number 2. If I want to make it into 3-port devices, so I just will add one. I'll just add port number another waveguide which is coupled to this one, and that is here, this is known as the port number 3. Clear? So now say, let's say this one is a normal waveguide. Clear? This one is a normal waveguide. And this port number 1, and this is port number 2. This is a normal waveguide, rectangular waveguide. Now if I want to make it into T junction, so I'll just add another port to this one. Clear? So this one is, if I say I'm adding this port into this, along this direction, so that was it is known as the E plane T. Now if I add this waveguide, this junction, or this another waveguide in this dimension, along this dimension, that will be known as the H plane T. So why it is known as the E plane T? Because E plane T is a waveguide in which its side arm is parallel to the E field of the main waveguide. This is the main waveguide, and this one is the side arm or side waveguide. The side arm is parallel to the what? Electric field of the main waveguide, like this one. If I say main waveguide has a clear, the main waveguide has this one, so the side arm is parallel to the electric field of the main waveguide. So that is why it is known as the E plane T. Clear? So now see, if I say this can also be act as a power divider. In this, if electric field is fed at the port number 3, then the whole power will be divided into two parts, that is in opposite phase, that is in port number 1 and port number 2. Now see, if I say whole input is provided to this one, means the output will be, the power will be divided into two parts, that is port number 1 and the port number 2. But if I say the port number 1 has this output, electric field is in this direction, then the port number 2 will have the direction of this one. They will be out of phase. Clear? Now see from this one also. If I say now see, let's say this one. if I say this one is the input port, this is port number 3, which is act as a input port. The electric field is in this direction. So electric field is this direction. Now let's say this one, this goes like this one, because this electric field needs to have a some endpoint which is of higher potential, because electric field move from lower to higher potential. So at that point, after this, after I am getting this T point, so after this the electric field will be in this direction, and this electric field at this point will be in this. You will see that the both port have the electric field at the output, but in the opposite phase. Clear? So now see, this can be act as a power divider. Clear? Alternatively, when applied as a power combiner, electric field at port number 1 and port number 2, that will be subtracted at port number 3. It means if I say this E plane T can also be act as a what? Subtractor. Now see, if I say port number 1 is act as input 1, and at port number 2, at port number 2 at port number 2 there is another input, then both input, if I say this is input port number 1 and this one is port number 2, then the output at port number 3 will be what? Will be input 1 minus में input 2. Clear? Clear? Now see, if port 3 is symmetric, wait a second. If port number 3 is symmetric, then the amplitude of the electric field divided port number 1 and port number 2, okay, from port number 3 will be equal, and hence at match E plane, T junction can be used as a 3 dB power divider. What does it mean? If I say port number 3 is symmetric, if I say that port number 3 is symmetric, the amplitude of the electric field divided port number 1 and port number 2 from port number 3 will be equal, and hence as a match E plane T can be used as a 3 dB power divider. Means if I say if port number 3 is act as a match termination, then the power is divided into two parts, that is not a 3 dB coupler but having a opposite phase. Now see, further, if the field at port number 1 and port number 2 are of same amplitude and phase, then the output power P3 will be 0 due to phase cancellation. Means if I say port number 1, at port number 1 this is the input, and this port number 2 has another input. At the output I am getting P2 minus P1. If both the input have the same amplitude and within same phase, then the output will be at P3 will be equal to 0. Clear? That is known as the P2 and this is known as P1. Clear? So that is known as the P3 will be 0 due to phase cancellation. Clear? Now if I say this input has another opposite phase, then P3 will be P2 plus में P1. Clear? If P1 input has some phase and P2 has the opposite phase, then there will be a P3 will be equal to P1 plus में P2. Clear? Now see, I want to draw the S matrix for the determination of S matrix for the E plane T. So S matrix is given in this one, that is S matrix. This is a three plane equivalent circuit. This is equivalent circuit of E plane T junction. This is port number 1, port number 2 and port number 3. Clear? Now see, if I say this is a 3-port junction, 3-port device, means its S matrix will be is in this form: S11, S12, S13, S21, S22, S23 and S31, S32 and S33. Clear? So S matrix, scattering matrix, this is known as the scattering matrix. And why we are using this scattering matrix? We already told you that S matrix is used at the microwave frequency. I cannot use the ABCD parameters for the microwave frequencies. Clear? Now see, S equal to S11, S2, this will be your S matrix has some properties. Scattering matrix has some property. Scattering matrix defines the voltage and the power at the output. Clear? And S matrix will also always be a square matrix. S matrix also have some property, that is S matrix multiply its conjugate will always be equal to identity matrix. Clear? And also that for the S matrix, it is a square matrix. I have told you for the S matrix, if I say this is Sij, so what does it Sij represent? Sij represent what? This J represents what? Input, and this I represents what? Output. Means if I say P1 is the input and I am getting a P3 at the output, P1 is input and P3 at output, so I will say that the S1, S3, 1. Clear? So this is Sij. J represents the input and this represents your output. Plus में, as this is a property of S matrix, that Sij is equal to Sji when what? I is not equal to J. Clear? Means if I say S13, it will be equal to S31. S12 is equal to S21. So this is a property of S matrix. Now see, this is a E plane T. This is a E plane T. Now see, if I am assuming that the S33 is a perfect network, match network, then S33 will be represent what? It will be equal to 0, because this is input and this is output. As if I say the port number 3 is a match network, then S33 will be what? Equal to 0. Clear? Now see this one. I will to do the S13. This is a matrix. Now see, matrix, this one is the matrix. Assume that the device is passive and made of a isotropic material, then the device will be reciprocal, because I will to this is a S matrix property. S12 will be equal to S21, S13 will be equal to S31, S23 will be equal to S21. It means I can say that the S matrix will be equal to what? S matrix will be equal to S11, S12, S13. It can also be written as S12, S22, S23. This can also be written as S23. No, S23. And this is can be written as S13, and this one is S33. Because why? Because S13 is equal to S31 and S21 is equal to S12, and S23 will be equal to S32. Clear? Now, as a result, this is all due to the property of reciprocal property. S matrix is a reciprocal property. Now, likewise, if I say the all ports are matched, then S11, S22 and S33 will be equal to 0. That's why as a result, lossless reciprocal devices will have a scattering matrix will be equal to S11 equal to 0, S22 equal to 0, S33 equal to will be 0, S21 will be equal to S21, S12 will be equal to S21, S13 will be equal to S13, and S32 will be equal to S23. Clear? Now see, this is the another property of S matrix, that if the network is lossless, then it must satisfy the unitary and the zero property. Unitary and zero property means it must satisfy the S matrix multiply में its conjugate will be equal to what? Identity matrix. Means if I say that S11 S matrix multiply its conjugate, that is S11, S12, S13, similarly S21, S22, S23, S13, S23, S33 will always be equal to what? Identity matrix 1 0 0 0 1 0 and 0 0 1. Clear? Clear? So now see, when I said this is a S matrix, so on multiply both the equations, on multiply R1 into में C1, on multiply में R1 into में C1, R2 into में C2 and R3 into में C3, you will get S21 का स्क्वायर प्लस में S31 स्क्वायर will be equal to 1, S21 स्क्वायर प्लस में S32 स्क्वायर equal to 1, S31 स्क्वायर प्लस में S32 equal to 1. Clear? Plus S31 dot conjugate of S32 will always be equal to 0. This is a property of the S matrix or zero property. It must satisfy the unitary and the zero property because as the network is the lossless. Clear? Now for the E-plane T, if I want to calculate the scattering matrix for the E-plane T, I have already told you what is E-plane T. E-plane T, if I say this is input 1, this is input number 2 and this is port number 3. This is output, sorry, this is port number 3, that is I say P3, P1 and P2. Clear? And these port are in the same plane, that is known as the collinear arm, and this is the in different plane, this arm is in different plane, that is known as the side arm. Clear? Now if I say, as we know, if I want to calculate the scatter matrix, what is this property? E plane T have a property what? That if I say P3 as an input, if I say P3 as an input, then P1 will have some phase and the P2 have some out of phase with respect to P1. Clear? Now see this one. This is E plane T. If I say port number 1 has this input and port number 2 has this input, the output will be in this phase, because output will be what? At P3 will be equal to what? P1 plus में P2. Clear? Now if both inputs have the same phase, if P1 have the same phase and the P2 if has the same phase, then P3 will be equal to what? 0. Clear? Now see, if I say this is act as an input, P3 is act as an input, then what will be? P1 is having this phase and P2 will be having a out of phase with respect to the P1. Clear? Now see, as the wave propagates through the sine wave, the bending of this wave take place at the junction. I hold the bending of this wave take place at this junction. Due to the junction symmetry, the amplitude or the power delivered to port 1 is equal to the port number 2. Means both have the same power. If I say this is act as an input, the output at the port, the power P1 and P2 will have the same amplitude, but that will be of opposite phase. Now when the electric field waves enter from two collinear arms, if I say the both are act as a input, if I say both act as an input, the two waves get added. If electric field entering from two collinear arms have the same polarity, and the waves will get cancel out and the port 3 will have the 0. If the same amplitude, same phase, output will be 0. If opposite phase, then the output will be added. Clear? Now for the S matrix, since there are 3 ports, S is a 3 cross 3 matrix, that is this one. Now I have already told you that input at port number 3, if input at port number 3, output at port number 1 will and output at port number 2 have same amplitude, but opposite phase. It means I say S input at the 2 will be equal to minus of S13. Clear? Now I am assuming that the port 3 is a perfectly matched, that S33 will be equal to 0, and from the symmetric property Sij equal to Sji, that means if I say that, I can say that the S12 will be equal to S21, S13 will be equal to S31, S23 will be equal to S32. Therefore the matrix will become this one. Clear? Now see, I have already told that if the network is what? Lossless, then S multiply में its conjugate will be equal to identity matrix. Means S multiply में S star will be equal to I. On multiplying this one, S11, S12, S13, S22, S13, clearly S33 equal to, on multiplying these two equations, R1 C1, R1 multiply में C1, R1 मल्टीप्लाई में C1 you will get S11 का स्क्वायर प्लस में S12 का स्क्वायर प्लस में S13 का स्क्वायर. On multiplying R2 into में C2 you will get this one, and on multiplying R3 into में C3 you will get this one. Now see, from these two equations you can conclude that this is S13 plus S12 and S12 plus में S13, you will conclude the S11 equal to S22 from equation number 1 and 2. From equation number 1 and 2 you can conclude that the S11 equals to S22. Clear? Now see, from equation number 3 you can conclude that the S1 twice of S13 का whole square equal to 1, that is S13 equal to 1 by root 2. S13 will be equal to 1 by root 2. Clear? Now see, or you can also say that just put this value here. From equation number, now on multiplying R3 into में C1, R3 row number 3 multiply में column number 1 3, you will get this equation. On you have already used at the S13, take a common, S13 common, S11 minus में S12 का whole star equal to 0. As we know that the S13 is not equal to 0 because I have that is S13 equal to 1 by root 2. It means the S11 minus S12 equal to 0. It means S11 equal to S12. So here I can conclude that the S11 equal to S12, and from this I can say that it is equal to S22. Therefore overall matrix. Clear? Now see this one, S11 is equal to, they both are equal, S13 is equal to 1. It means that S11 plus S1 plus 1 by 2 equal to 1. Put this S11 equal to, you will get 1 by 2. On putting this value, you will get S11 equal to 1 by 2, S11, S12, S22 equal to 1 by 2, S13 equal to 1 by root 2. You will get, on putting this value S matrix, you will get this S matrix for the E plane T, on assuming that the if port 3 is the perfectly matched to the junction. Clear? Now see, if I say this S matrix can be represented, can be used as a to find out the output. This B is the output matrix, S is the scattering matrix for the junction, A is the input. So you will see that there are three inputs, three outputs. Port number 3, 1 and 2. Output, if I say output at port number 3 is known as B3, output at port number 2 is known as B2, B1. Clear? So B1, B2 and B3. Clear? And if I say this is, if I say P1 is act as an input, that is A1. If P2 is act as an input, that is A2. If P3 is act as an input, that is A3. So matrix multiply में A1 into में A3. You will get these two equations. Clear? From these you can conclude that the, if I say from these two equations you can conclude that the, if input at A3, if I am giving input A3 is not equal to 0 and A1, A2 both are equal to 0, you will see that the B1 will be equal to what? A3 divided by root 2, and B2, output at B1 is equal to A3 by root 2, and output at B2 will be minus of A3 by root 2. Clear? And similarly B3 will be 0. Now say, if I say third case, this is case number 1. For the second case, let's say if I say the input is input at port 3 is equal to 0, A1 and A2 are equal to A, then B1 equal to A, B2 equal to A and B3 equal to 0. It means there will be no output at port number 3 because both are same and have the same amplitude with the same phase, output will be 0. If both input A1 and A2 have the same amplitude but opposite phase, then the output will be combination of this one. Clear? That will be B3 equal to will be root of root 2 multiply में A. The book I have referred for preparing these slides is Microwave Devices and Circuits by SM Liao. Thank you.